a 450 grams ball at the end of a cord is rolled in an almost horizontal circle of radius 1.25 meters. Its tangential speed in the circle is 8.5 meters per second. Do not neglect the weight of the ball. The string cannot be perfectly horizontal. What must be the tension in the cord, and what angle does the cord make with the horizontal? Alright, so in this question we want to find the tension in the cord and also the angle that the cord makes with the horizontal. Now the horizontal is here. We want to determine the angle that the cord makes with it. If it was with a vertical, we would have determined this angle theta, so which is different in this case. Now what we are going to do is we are going to break the forces acting onto this mass which we have. So of course we have got this, the mass is there. We have got the tension in this cord. And because we are not neglecting the mass of the bulb, then it has got weight, and weight, that is mg. And at the same time, this tension can be broken down in two components, and we are going to have the x component and the y component. The x component goes in that direction, the y component goes up, the x component goes in this direction. So if we are talking about the angle theta here, we can see that if we draw a line which is going up in that direction, let me just put it well. If we draw a line which is parallel to the y component, we can see that this is going to be opposite. And that means if we are talking about these sides which is opposite, because these two are parallel, that means they are going to be equal in magnitude. And from our trigonometry, we know that sin theta is equal to opposite, and opposite is the y component here over the hypotenuse, which is the tension. So finding that y is going to be equal to tension sin theta. So let's just say that. So this is going to be tension sin theta. If the y component is tension sin theta, we can say that the x component is adjacent to the angle. So that we are going to use cos. That will be tension cos theta. Now, working with the forces in the y, the net force in the y is going to be equal to the tension sin theta going up minus the mg going down. So I'm going to subtract mg because they're going in opposite directions. Because this mass is moving in a horizontal circle, it is not going up, it is not coming down. The net force in the y is going to be 0. So this is going to be 0, and that will be t sin theta minus the mass here is 450 grams, which divided by 1000 is going to give us 0.45 to take it to kgs. So 450 divided by 1000 gives us 0.45, and g, that is 9.8. So this term we can see that it is negative, so I'm going to take it over the other side, it becomes positive. And so I'll just start with t sin theta. And taking this thing the other side, we know it's going to become positive if it goes on the opposite side. 0.45 multiplied by 9.8. That gives a value of 4.41. So this will be our first equation. Now considering motion in the x or in the horizontal, there is always a force pulling this mass towards the center, and that is the centripetal force. And we can see that in this case the centripetal force is due to the x component of the mass. Okay, the x component of this tension, which is this one, t cos theta. So we're going to say centripetal force is equal to t cos theta. Centripetal force is given by mass times velocity squared divided by the radius, and that will be t cos theta. I can start with t cos theta, and that will be equal to, where there is mass, we are putting 0.45, and the linear velocity we've been given, that is the tangential velocity or the tangential speed, which is 8.5. and then that square divided by the radius. The radius also been given as 1.25 meters. So this gives us t cos theta being equal to 0.45 multiplied by 8.5 squared divided by 1.25. So that is going to be 26.01. Alright, now we know t sin theta and we know t cos theta. We know when we divide sin by cos, we get tan. So what we are going to do is exactly that. We are going to divide this one by the second one. So t sin theta divided by t cos theta should be equal to 4.41 divided by 26.01. Alright, so that will be it. And I can just remove this space. So we can see t and t is going to divide us sin theta over cos theta, that is tan theta. And that would be 4.41 divided by 26.01. That is 0.169550. So theta here is going to give us, we'll take the tan inverse of 0.169550. So that is giving theta of 9.62 degrees. So that is the angle. Now what will be the tension in the chord? So we can use just this formula here. Tension cos theta is equal to 26.01. That means tension is equal to 26.01 divided by cos theta. And so this will be tension is 26.01 divided by cos. The angle theta is 9.62. So tension is going to be 26.01 divided by cos 9.62. And that is giving me 26.38120922, which to just the three significant figures we can write as 26.4. This is in newtons. So that is going to be all for this video. Thank you so much for watching. Please be sure to subscribe and follow more on the videos.